Today I've got a problem from TBO's problem solving booklet designed for students preparing for the Oxford and Cambridge mathematics interviews. I know a lot of you this week have had your interviews at Cambridge for maths, and I think maybe a couple with Oxford, but most of Oxford's one are this week. So if you're watching this and you have an Oxford maths interview or a Cambridge one, best of luck. Anyway, let's dive into this one. We have the points A, which has coordinates 6, 0, and B, which has coordinates 0, -4, are points on a triangle. The third point lies on the graph y equals x squared. We want to find the coordinates of the third point, which minimizes the area of the triangle. So I've kind of drawn up here this parabola, y equals x squared, and these points A and B. And we have a third point which lies somewhere on this parabola. Let's maybe imagine over there. And that minimizes the area of this triangle, like so. And we want to find the coordinates, let's call it C, of that point. Okay, I encourage you to to have a go at this problem, but I'm going to dive into a solution here. Firstly, notice that this third point C must have a non-negative x coordinate. How do I know that? Well, let's say it had an x coordinate that was negative. Well, that area of that triangle is very clearly going to be bigger than the area of this triangle here. Um, so we can definitely get a contender for a minimum by choosing the origin, and any negative x coordinate doesn't, gives us a bigger area. So we needn't worry about x being negative. We focus on maybe x being 0 or positive. So let's just choose the x coordinate of C, the third point, to be somewhere there. And let's call the coordinates of C very conveniently lowercase c, and then the y coordinate will be c squared. Okay, great. We want to work out the area of this triangle in terms of C. And I'm going to do this by splitting this into two triangles, this top triangle and also this bottom triangle, like so. And I notice at this point here, the x coordinate of the point of intersection of BC with the x-axis is going to be of importance. So maybe let me label that alpha. Okay, great. Let's work out the area of this top triangle. Well, the area is going to be half times base times height. The base is going to be 6 minus alpha, and the height is going to be c squared. Great. What about this bottom triangle? The area of that's going to be half times base, which is 6 minus alpha, and the height is 4. And so that's going to simplify slightly to 2 times 6 minus alpha. So the total area is equal to a half 6 minus alpha. Oops. Then if I factor this out, so I get c squared plus 4, like so. Amazing, lovely. Okay, now I want to work this out ideally in terms of C, and then I can work out which value of C minimizes this. So I need to get rid of this alpha. So maybe I need to work out the coordinates of alpha in terms of C. That's not too difficult to do. We can just consider this line BC. So how do I work out the equation of this line BC? Well, I first need to find its gradient. So the gradient of BC, well, I can just do change in y divided by change in x. So that's c squared minus 4 over c minus 0, which is c squared plus 4 all over c. And so therefore, the line BC is going to have equation y plus 4 equals c squared plus 4 over c times x. Great, so that there is the equation of BC. Okay, how do I use that to find alpha? Well, that's going to be when y is 0. And so just plugging in y equals 0 here, I get that alpha equals 4c over c squared plus 4, like so. So just making y 0, that term vanishes, and making x the subject gives me 4c over c squared plus 4. So if I just substitute this in here, it's getting a bit tight, but area is going to be a half times 6 minus 4c over c squared plus 4. And this is where things get nice, multiplied by c squared plus 4. And so all in all, this is just going to simplify to a half times 6c squared plus 24 minus 4c, like so. And now our goal is to just minimize this area. And this is just a quadratic, so it's pretty easy to minimize. In fact, I'm not going to bother doing it here. All you'd have to do is use completing the square to find the value of c. And then whatever that value of c is, you simply substitute it in, and that gives you your coordinate c. I'm going to be a bit lazy here, but that's not super exciting. Anyway, I hope this does help, and hopefully, you maybe get a similar problem in your interviews, and you'll be in good standings. But do let me know if you enjoy these sorts of videos, me going through interview problems. And best of luck if you do have an interview in the next few days. Thanks for watching. I'll catch you in the next one. Have a great day.